Hey there! Today we're going to tackle a skill that seems super simple but is secretly running our entire digital world: ordering numbers. Getting this down is a huge key to crushing it in algebra and pretty much everything that comes after, so let's jump right in. So let's kick things off with a classic question like this one. Is 2/3 bigger than 0.6? Your gut might have an answer, but in math, a hunch isn't good enough. We need proof. And today, we're going to build the system to get that proof, every single time. And our go-to tool for this whole thing, the number line. The best way to think about it is like an infinite ruler, where every number you can possibly imagine, fractions, decimals, the whole shebang, has its own specific, unique address. So to use this ruler properly, we first need to understand the one fundamental rule of the road. And it's honestly this simple. Ordering is all about location, location, location. If a number is to the left of another one on the line, it's smaller. If it's to the right, it's larger. And if they land on the exact same spot, well, then they're equal. That's it. That's the core idea right there. Okay, so we've got the concept down. Now we need the right language to actually talk about it. Now, what's really cool about this is the little cheat code for the less than and greater than symbols. You might remember the alligator mouth from school, which is fine, but here's an even simpler way. The pointy end of the symbol always points to the smaller number. Always. Doesn't matter if it's less than or greater than. Find the smaller number, and you know which way the symbol should point. So we have the concept, we have the language. Now for the single most powerful strategy that's going to make any comparison a piece of cake. And here it is, the big secret. When you're looking at a jumble of different kinds of numbers, fractions and decimals mixed together, it's tough to compare them. The trick is to convert everything into one universal language: decimals. I mean, just take a look at this. Trying to compare 5/8 and 2/3 directly in your head, it's kind of a headache, right? But the second you turn them into decimals, well, the answer just jumps right out at you. You can see, clear as day, that 0.625 is smaller than that repeating 0.666. So we can say with total confidence that 5/8 is less than 2/3. See? The decimal strategy gives us a clean, undeniable answer. No guesswork needed. All right, that seems simple enough, right? But now we've got to talk about the one area where pretty much everyone gets tripped up at some point: negative numbers. Yeah, this is the thought that gets us into trouble. Our brain just sees the 10 and the 2, and it screams, hey, 10 is bigger, so negative 10 has got to be bigger too. But that's just not how it works on the number line. With negative numbers, you have to remember that the logic completely flips on its head. The bigger the number looks, we call that its magnitude. The smaller its actual value really is. That's why negative 10 is actually way, way smaller than negative 2. It's further to the left on that number line. You know the easiest way to get this right every time? Think about temperature. Seriously, would you rather be outside when it's minus 10 degrees or minus 2 degrees? Minus 10 is way colder, right? That means it's a smaller value. Okay, so let's put it all together. We've got our decimal strategy, we know about the negative number twist. It's time to take a totally jumbled mess of numbers and bring some perfect order to it. So here's our challenge. Order this list. We've got negative 2, 0.5, negative 2.3, 0, and 3/4. Right now, it's just chaos. Our mission is to line them up from the smallest value all the way to the largest. And we've got a super simple two-step plan. First, we use our secret weapon. Convert everything to decimals. The only one we really need to change here is 3/4, which becomes 0.75. Easy. Step 2, we just find their locations on the number line, starting with the one that's the furthest to the left. And there it is. The number furthest to the left, the most negative, is negative 2.3. Next up is negative 2. Then we cross that big landmark at 0. After that comes 0.5, and finally, the largest number in our list is 3/4, or 0.75. We went from total chaos to perfect logical order. Okay, so why does any of this matter? Why spend all this time ordering numbers? Well, it turns out this fundamental skill is running the world you interact with every single day. And this right here is the crucial takeaway. This is not just some math class exercise. The simple act of comparing two values, is it less than, greater than, or equal to, is the tiny little engine that powers almost all modern technology. Think about it. Every single time you see a ranked list, your Google search results, your Netflix recommendations, even the files in a folder sorted by size, it's all powered by a sorting algorithm. And that algorithm's entire job is to just make millions of these simple comparisons, A versus B, over and over again at lightning speed. Which leaves us with a final thought. This simple comparison is the bedrock. If a computer lost the ability to do this one basic thing, to decide if A is less than B, what else would stop working? What part of your digital life would completely fall apart? It's pretty wild to think about. Thanks for joining me.